right, I'm gonna show you guys a few problems from page 21 of the summer packet, the last page of the summer packet. And this entire page is about solving systems algebraically, and there's a few methods that we've gone through. One is through elimination. All right, I'm gonna show you a real simple elimination, which is the same as problem 2 on your summer packet. Then I'm going to show you a very simple substitution, which is going to be problem 7 on your summer packet. We'll discuss a little bit one of the harder problems, maybe problem 9, and then I'll show you one solving by graphing. All right. Elimination is often called combination because what you're doing is you're combining one equation with the other through the addition, right? And it's also called elimination because your goal in combining those two is to eliminate one of the variables. And if I just add straight down, I get 6x is equal to 12. Dividing both sides by 6 to solve for x, I get x equals 2. And we've already halfway solved for this. All right, we know x is 2. I can take either one of these equations and plug it back in. That would make this 3 times 2 plus y equals 5 if I use the first one. Multiply and solve for y by subtracting 6, and I get y equals -1. And with a problem like that, you're already done. All right. You can check it in the bottom equation if you want. That's 6 plus 1, which is definitely 7, minus a -1 right there. Substitution. Substitution is used a little less often when solving systems. But one time you probably want to use it is when it's already solved for a variable. That's already solved for y. So I know in this system, y is always equal to twice x minus 1. So what that allows you to do is it allows you to plug that in for this y in the second equation. So if I go 3x plus 2, and instead of y, I write 2x minus 1 equals 16. And then we just solve like we normally solve. This is a multi-step problem, but no problem for you guys. I distribute that 2 and get 4x minus 2. Combine like terms, 7x minus 2 equals 16. Make sure I did everything correct here. Did I write the right problem? You know what? I wrote the wrong problem. This should have been a plus. That should have been a plus, and that should be a plus 2. So I'm going to subtract 2, and I get 7x equals 14, which gives me x equals 2. All right. When you get your x equals 2 on this one, you can plug it right back into this first equation, which gives you y equals 2 times 2 plus 1, and 2 times 2 plus 1 is 5. And then we got a solution of x, y. So our solution has to do 2, 5, and that would be the solution for this equation. All right, there's 2. There's only 9 problems. I'm at least going to start 9 for you. All right, so I'm going to throw a 9 up here. And I'm going to say 5 times 5x minus y equals x plus 20. I'm going to move it over so I can set the next one right out here. We got 3x plus 8 equals 4x minus 2y. Make sure that fits, and it does. I'm just going to go down and kind of simplify these a little bit. If I distribute that 5, I've got 25x minus 5y equals x plus 20. And let's go ahead and let's get our x's and y's on the same side. All right, so if I subtract 4x here, we're partially there already. Which gives me -x plus 8 equals -2y. You know what? Let's go ahead and add x. And then we'll just write the right side on the left side. So we could say x minus 2y equals 8. I just took these two, brought them to this side. As long as you keep numbers as signed numbers, you're good. And then I brought this guy over here. And then on this side, let's go ahead and do the same thing. Let's bring the x's over. If I subtract x, I get this. I get 24x minus 5y equals 20. Now, what we have to do is we have to figure out a way to make these guys cancel out. You can do it real easy with the x's, but I'm multiplying by a huge number to turn this into the opposite. So we want to make our coefficients opposite. And probably the easiest way is to deal with these y's right here. 2, this coefficient, and 5, this coefficient, have a common multiple of 10. Let's do this. I'm going to multiply by -5 so that their coefficients are opposites, which gives me -5x, bring it in here, plus 10y equals -40. I'll multiply this whole thing by 2, which gives me 48x minus 10y equals 40. Then I'll line these up and I'm going to use elimination. So I'm going to bring this guy under here. -5x plus 10y equals -40. And we got something nice happening here. Everything but the x's are going to cancel out. Alright, these guys turn into a 0, the y's cancel out, and I get 43x equals 0. When we divide by 43, we get a nice answer, x is 0. Now, any problem that you see up in this system right here, we could plug x in for. This system right here, we could plug x into. We could even plug it into the adjusted problems, equations that we have. But I'm going to go ahead. This one looks the easiest, top right. So I'm going to say x equals 0. And let's go ahead and say, we'll write it again down here. 3x plus 8 equals 4x minus 2y. All right, which gives me 3 times 0 plus 8 equals 4 times 0 minus 2y. We can see that this and this multiplied by 0, they cancel out. I get 8 equals -2y. When divided by -2, we have a solution. We got y equals -4. All right. So that's probably the hardest problem on there. Let's write it as an ordered pair, 0, -4, and show you one more problem. It's already a longer video than I would like, but these aren't too bad.